So we've done numerical indexing. Now let's move on to indexing using our range operators. Recall the way you do range is you give it a start, colon, give it a step, colon, and then you give it a stop. And you may or may not equal that stop value depending on how your start and your step work out. And so you can also index a vector using that. So what does that mean? Well, okay, let's start off with the vector A, and let's give it the following values: 5, 8, markers 9, 9, 2, 4, 7, 1, 3, 6. So all these have spaces in them, so all these are single digit values. So I can put the commas in here for clarity. Okay? 8 looks really bad. Okay, and remember once again, this is setting up memory locations. So A, five, 8, 9, 2, 4, 7, 1, 3, and 6. And then this is memory location A1. This is A1, A2, A3, A4, A5, A6, A7, and A8. Okay? Oh, excuse me, and A9. Okay, so now I'm now going to index this with my range operator. So let's go in here and say, all right, give me A indexed at 1. So this is using a vector to index a vector. So index it at 1, 2, 4. Okay, what that's going to return is the element in A at 1, which is 5. So it's going to return a vector that's been indexed at the first value, which is 5, the second value, which is 8, and the fourth value, which is 2. So it's 5, 8, 2. What if I said, give me A at, now keep in mind the other, the other way to do the range is to do start, colon, stop, and that assumes that the step is equal to 1. Okay? And so if I did A indexed at 2, colon, 6, keep in mind 2, colon, 6 is just like writing A indexed at 2, start at 2, stop at 6, step 1 each. So that's like indexing at 2, 3, 4, 5, and 6. So if I indexed at those at 2, 3, 4, 5, and 6, then that's going to give me the vector A indexed at 2 is 8, A indexed at 3 is 9, A indexed at 4 is 2, A indexed at 5 is 4, and A indexed at 6 is 7. So there you go. Wow, marker's really dying here. And so that would give me this vector there, 8, 9, 2, 4, 7. So what you do is whatever range is in here tells you the addresses to go to in the vector. So if I did A at 2, colon, 2, colon, 6, that's like doing A at 2, 4, 6, which will give me the vector A at 2 is 8, A at 4 is 2, and A at 6 is 7. So that gives me the vector 8, 2, 7. And I did not mention this in the range discussion, so I'll mention it here, or maybe I did. If you do, you can do 3 colon end. So any range will count, however you do the ranges. So this is like saying A from 3, 4, 5, 6, 7, 8, 9. And that will return the vector A at 3 is 9, A at 4 is 2, A indexed at 5 is 4, A indexed at 6 is 7, A indexed at 7 is 1, A indexed at 8 is 3, and A indexed at 9 is 6. So that would return that vector. Any vector, any way you want to create a range here, just tells you, it's like having a list, or it's actually having a vector of indices here, and you index A at that vector. So you're indexing a vector with a vector. And so that's how the range works. That's how range indexing does. Next up, we'll do logical. So now we're going to index vectors using the range operator. Just for a reminder, let's remember with the range operator, it works as start, colon, step, colon, stop. And the last one may not be included. Excuse me. And sort of the shortcut of that, if you only have 2 values, start, colon, stop, then it is assumed that the step is 1. Okay? All right, with that in mind, let's create a vector A once again. And let's do direct entry and get a few things in here. 5, 8, and I don't really need the commas, so let's use them. 5, 8, 9, 2, 4, 7, 1, 3, 6. Okay. And let's suppress that. Okay, so if we did A indexed at, so before in the last slide we were doing numerically, we would just index A at 1 like this. Now we're going to index with a vector, so we put a vector in there, and we can index it 1, 2, 4, and do that. Okay, so let's run that. It's going to ask me to save. I'm going to call this my vect indexing range. Okay, and if you notice, all the right things happened. It gives me an answer because I did not suppress a 5, 8, 2. If we go over here and look, this is our vector 5, 8, 9, 2, 4, 7, 1, 3, 6. And if we index it the first, second, and fourth locations, the first one's 5, the second one's 8, and the fourth one is 2. So it worked out like we wanted. Let's go back and make that equal to B. So next time it runs, we'll get a good variable in there. All right, so next up, let's do A index at, now let's use the range operator here. Let's use 2 colon 6. Now keep in mind, 2 colon 6, that gives us the vector 2, 3, 4, 5, and 6. So this is equivalent, if I had to, let's see, C is equivalent as if we had typed in 2, 3, 4, 5, and 6. In fact, let's do that. And let's make B equal to A indexed at 2 colon 6. And let's run this. see what we get. Well, we get C and D are the same because they're indexing, and go over here to the workspace. They're indexing at the second, third, fourth, fifth, and sixth. So second, third, fourth, fifth, and sixth. So it's 8, 9, 2, 4, 7, which is what we got here. All right. So very good. Next up, we can do things like, let's see, E equals A indexed at 2, 6. Okay. And so what does that say? Well, that says start at 2, end at 6, and do every other one, or increment by 2. So that's the equivalent of doing, if I did F, that's the same as doing 2, 4, 6. This is why understanding the range operator is so important, because you're going to do this a lot over the course of MATLAB. And so if you look, it's 8, 2, and 7. Look at E and F here, it's 8, 2, and 7. Once again, the second, fourth, and sixth element in array A. Okay? All right. And then there's some other things. Oops. Some other things we can do. We can, and I may have not mentioned that you can also do the AND operator with ranges. So let's just say if I said you could do G equals A index from 3 to the end. That means that would be 3 all the way to the last element. And so if I do this and run it, sure enough, I go from the third element all the way to the last. The third element is 9, 1, 2, 3, and then all the way through the end, which is 6, and that's vector G. Okay. It also works the other way in terms of assignments. I can assign values to a vector. So let's say if I go in here and I say A at 1, 2, 3 equals 99. Now, there are two things to note here. What I'm going to do is I'm saying assign the value 99 to the memory locations in A at index 1, 2, and 3. And so when I run this, it does that. And so now A, the first 3 elements of A are 99. Okay? Which that's fine. Now let's move on. Let's say if I said, instead of do it that way, let's say if I say A at the 4th, 5th, and 6th elements, assign that, replace those elements with the vector 101, 102, 103. Right? And I run this one, and that works fine as well. You see, I replaced those 3 elements in the vector at locations 4, 5, and 6 with the values 101, 102, and 103. So it shows up here in the workspace and down here in the command window. So that works fine. Now, where you get into trouble is if I did something like, let's say if I wanted to do elements 7, 8, and 9, and I wanted to give those the values -1, or let's just say not -1, let's say 0 and 1. Now, we're going to get an error here. So when I click this, it gives me an error. The problem is that if you notice here, I've tried to replace 3 elements with only 2, and that doesn't work. That doesn't match for MATLAB. It's got to be either a 1 element, or what we call a scalar, or the number of elements that you're replacing have to equal the number of elements in your replacement vector. So here we were assigning the same number to all 3, and here we're replacing these 3 elements with these 3 elements here, right? This line 14 gives an error,
because I'm trying to replace 3 elements with 2 elements, and MATLAB doesn't know what to do. So that's something. So the rule is it has to be a scalar like this. This is called a scalar value, which is just only one value, and then they have to be of the same size, and that comes up over and over again in MATLAB. This generates an error because it's not the same size, nor is it a scalar. So that's a little bit extra that wasn't in the onboard stuff that I just talked about, but we'll see that coming up as we proceed forward.